Hi, I'm Gabriele Moreno Berton, and I'm going to present our work on adaptive attentive geolocalization from few queries, a hybrid approach. In visual geolocalization, the task is to recognize where a given photo was taken. This is usually cast as an image retrieval problem, where we have a gallery of images for which we know the location, and we need to find out the location of the query by looking for the most similar image in the gallery. Our focus is on the more challenging geolocalization across domains, where the domain gap between gallery and query can be due, for example, to environmental and lighting conditions. Most works focus on the single domain task, while very few approach the cross-domain geolocalization, and as commonly done with datasets with the domain shift, the task is approached with domain adaptation methods. This is achieved through generative models, by transferring the style of the images, or through discriminative approaches, where the goal is to learn domain invariant representation. In order to address the problem, we need a multi-domain dataset. However, existing datasets cover a limited geographical area, have a limited number of domains, or are collected in rural environments. Here is shown the Robocar dataset, for which we chose 5 available domains, and you can see that the size of the dataset is very small. Therefore, we extended the Robocar dataset with a new one called Street View Oxford, or SVOX, which we use as labeled source domain images, while using images from Robocar as unlabeled target images for a domain adaptation task. As you can see in the bottom left images, the domain gap between the domains is due not only to environmental conditions, but also to the position and orientation of the camera. Our architecture is made of 2 parts, which are trained in 2 phases. Phase 1 is for training a few-shot domain-driven data augmentation by employing an autoencoder architecture to generate new images. Using just a few target domain images, we are able to transfer the target domain style to the labeled source domain images, therefore generating new images for which we have the labels, and that belong to a domain similar to the target one, which we call pseudo-target domain. In phase 2, we train the core of the architecture. This second part takes as input images from the 3 available domains: source, target, and the previously generated pseudo-target. We employ an attention layer which helps the model to be more robust to domain shifts by effectively focusing the embeddings representation on highly informative static objects, such as buildings. As shown in the bottom right images, the attention layer is able to generalize well to the target domain, even though it does not receive target domain images at training time. Then we employ a domain adaptation module to force the model to learn domain invariant embeddings between the 3 domains. The combination of the attention layer, the generation of pseudo-target domain images, and the domain adaptation module ensure that the architecture is highly robust to domain shifts, even in a few-shot scenario, where we have just few available images from the target domain. Moreover, the usage of a generative and a discriminative method to tackle the domain adaptation problem makes this the first work to employ such hybrid architecture in visual geolocalization. Here you can see some quantitative results. The second column shows the number of target domain images used at training time for domain adaptation, and as you can see, we only use 5 target domain images, while other domain adaptation module methods use the whole target set. Even with this disadvantage, we are able to outperform all pre-existing methods by a large margin on all 5 target domains. Here you can see some qualitative results from the snow target domain. You can find more quantitative and qualitative results on our paper. Here is the bibliography. And here are our contacts and the link to the code. To obtain the new SVOX dataset, please send us an email. Thank you for your attention.